But what if I told you that too much rigidity can be a problem? Nice, right? Let's discover why.
Technical explanation. We're facing a damping issue. Our mini lathe has very low mass, which means it can't effectively dissipate resonance. Small mass combined with high cutting forces leads to minimal vibration absorption. If the ways and gibs are too stiff, and the spindle's angular contact bearings are overly tight, we eliminate the system's ability to absorb and dampen vibrations. Instead of dissipating energy, the structure reflects it, amplifying resonance and causing chatter or poor surface finish. Distributed damping concept. In theory, adding a dedicated damper could help control resonance. But in practice, our problem is distributed across multiple mechanical causes. Times over-tightened spindle bearings. Times excessively stiff joints in the ways and gibs. Times lathe carriage rigidity. That means our damper unit isn't a single component. It's a combination of adjustments. By tuning each element, bearing preload, gib tension, mass distribution, we create a system-wide damping effect. The goal is to find the best compromise between surface finish and machining precision. Outro. Rigidity without damping is like a bell with no cushion. It rings, it resonates, and it ruins your finish. Balance stiffness with smart absorption, and your mini lathe will perform like a precision machine. Subscribe for more hands-on mechanics and let me know what you'd like to test next. Distributed damping strategy in mini lathes. Red circle spindle bearings, check preload. Orange circle Gibbs weighs, tune stiffness. Green circle carriage, allow micro movement. Blue circle lathe base, add mass. Purple circle tooling, use damp tools. 1. Causes of resonance. Component problem effect. Spindle bearings too tight, vibration reflection. Gibbs weighs excessive stiffness, no energy dissipation. Lathe base low mass, amplified resonance. Tooling, no damping, chatter during cut. 2. Solution summary. Adjustment purpose result. Loosen bearings, reduce stiffness, better absorption. Tune Gibbs screws, allow micro movement, less chatter. Add mass to base, increase damping, lower resonance. Use damp tools, absorb tool vibration, smoother finish.
And now it came the time to check point 1, spindle bearing preload. Maybe I tied too much. To prove that, let's check here, first of all, if we have some gap. Let's put any is 0. As you can see, doesn't move. This one is fine. Now let's take this one. Doesn't move. I don't force too much, of course. Don't even 1 micron move. I want to check another things. So here put a lot of force. Lateral we have 10 micron deviation, but it's normal. So what to do now? Let's run the machine 45 minutes. And I put at 600 RPM. Now let's open here and check the temperature. Say 27 degrees. The engine is 28, 27.5, 27.5. I don't know if you can see. $27. Now let's open here. And let's check inside the temperature near the tube bearings. 28.2. Let's check here. 29. I don't think so is if it was to here the spindle is 28.2, but I don't think so that is over tight, otherwise the temperature will go up. But let's check in half an hour time. See you later. Now let's check, is over half an hour that is running. The sound is the same. I can touch with my hands just, and I can see that is not too hot. 34.4. So it's quite. Also here the spindle 32.7. 34.6. Let's check also here. 31.8. Now let's check again. The engine is 45 degrees. Let's stop here the machine. Let's place this one again here in any even number, it's not a problem. Let's check again this one, and doesn't move. I don't think that are the spindle bearing are not too tight. I think that is fine, and I will not touch. Let's put back this one and let's make the 0.2 test. Let's check gibs and let's tune in a better way the screw in order to release stiffness. Frankly, I think that this is the problem, because I can feel that is a little bit gummy, you know. I think that should not be in this way. And also, if I light on the arrow, I switch to 0 this one. Look, it's not consistent, you know. 830. You can see that it's very difficult for me to reach the desired measurement. This means that is work in this way, and I think that this is reflecting here. Let's check. Let's put back now the screen. Frankly, I think that the carriage is the problem. Now I need to remove this carter. In a way, I don't want to disassemble everything, you know. I'm forced to remove this one. And two. But at least this is you remember to protect the lead screw. I place this one here. I want to check one things. I adjust a little the gibs, and now let's put back this one. Okay. For the moment we have to fix this one when it's working. And now let's check again. .5. Not too bad, right? Now let's check when we cross here, because there is a double depth. Beautiful finishing, my friend. Yeah, for sure was over 3 millimeter, you know, for this finishing tool is too much. For sure, with 0.3 we should add mass to the lathe, but in this moment I don't have any solution for that. And I know that I can still improve, but I'm quite satisfied for the moment. The finishing, guys, is beautiful, you know. Check. I don't know if you can see. Beautiful, right? And it's much better than before. Let's give now 0.5 millimeter, and after we try with 1 millimeter. And this small lathe work better with a sharpen edge, you know, tool, and not high radius tool. Let's try to add the speed. Nice. Let's stop. Go out. 1 millimeter. Now I give another 0.5. From this point, start to cut 1 millimeter. Before start to screaming at 0.1. I will reduce the speed. Almost there. Start to be dangerous. But it's cutting, you know. And this is hard still, eh? Nice. Just arrived from Japan. This hardness tester. because this steel is quite tough. I didn't use a soft steel where is easy to work with our small lathe, but I use a hard steel. Now let's check how many Rockwell. This is from Tsubo-san, 6 pieces set from 40 to 65 Rockwell. Okay. This is 40. And this one is 45 and start to crab. Yeah, definitely. This one is 50 and you cannot do. So it's between 40 and 45 Rockwell. Those are pretty nice. I was missing that. It's a nice set. So guys, I hope that you liked this video, different from the other one, but this practically was the last chapter of my lathe service, and now I fix I tune better the gibs, and as you can see I will have much less vibration, resonance. And that was my goal. I know that I have still improved a little bit, but now it's better that I start to work on the lathe to check really if everything is running well. So thank you for watching me. I hope that you like. If yes, please put a like and subscribe. See you the next one.
Generate by AI.